Start.
Hi everyone, I'm Vanaja. I'm studying third year ECE in SRM University AP. Currently, I'm doing internship in Emertxe. Our project is home automation in IoT. Our group members are Yuvraj, Rajesh, and Ram Suryavamsi. Home automation. First thing, what is home automation? In simple terms, it means you can easily control the devices and the features of your home through internet to make your life more convenient and secure and even spend less on household bills. Home automation is a network of hardware, communication and electronic interfaces that work to integrate everyday devices with one another through the internet. Each device has sensor and is connected to Wi-Fi, so you can manage them from your smartphone or tablet, whether you're at home or miles away. This allows you to turn on lights, heater, cooler, etc. There are three main elements in home automation. They are sensors, controllers, and actuators. In this project, we are connecting all these devices like heater, cooler, LED, tank under one system. Next slide. Contents. We have learned about C programming, C++ programming, and project requirements. Software is used. Components. First code using LED and also CLCD, ADC, PWM, and temperature system. And Blynk app configuration, controlling devices using Blynk cloud server, and conclusion, etc. And C programming. We use C in this project because C programming has processor independent portability and performance and memory management. So we used C in this project. And we also learned about the characteristics of C and its keywords and categories. C code contains data representation like data numbers and data representation in bit byte word and basic data types like integer, character, int, floating point, float, double, and modifiers and qualifiers, conditional constructs like if else, else if statements, switch case, for loop, while loop, do while loop, break, continue. And operators like arithmetic operators, logical operators, relational operators, assignment operators, bitwise operators, ternary operators, and overflow signed numbers, and also underflow signed numbers. And we have learned about arrays, pointer, function, string, storage classes, preprocessor, etc. And we also have learned about C++ programming. Uh, in starting, we have learned about introduction to C++ and the main difference between C++ and C, and concepts of object-oriented programming and pillars of object-oriented programming like abstraction, encapsulation, inheritance, polymorphism, and C++ features and virtual functions and classes and its friends function, templates like friend functions and classes, standard templates, library, etc. And now Rajesh will continue this.
So my name is Rajesh, currently studying in SRM AP ECE third year. So when we enter into the topic, the first topic is an embedded system. So an embedded system is a microprocessor or a microcontroller based system of hardware and the software designed to perform a specific task. So when we go into the hardware of the embedded system is based on a microprocessor and a microcontroller. So the software and the software of the embedded system can vary in complexity. So when we go into the real-time operation of the system, they're not always included in embedded system, especially in small scale systems. So there are numerous advantages of these embedded systems, like they are easily customizable, and they are low power consumption, and they are low at cost, and they enhance the performance. So there are on the other side there are disadvantages also. So they are high development effort, and they are large. They require large time to a lot of time to market it. So next slide. So when we go into the project requirements, so the software we used, different kinds of software we used are listed here. The first one is an Arduino IDE. So next one is the picsimlab, and the next one is the Blynk IoT app, and the next one is a null emulator. And these are the related images regarding these softwares. So next slide. So here are the list of components that we have used in this in the software that we have used it. In the picsimlab, we have used an Arduino Uno board and an LED and an CLCD and a temperature system and an LDR sensor and a potentiometer and an Ethernet and a serial remote tank. So these all the components are used for the stimulation of this project. So next one, next slide please. So this is the first code that we have developed that we have written in this project. The first code, this is an LED code. So in this Arduino IDE, we have written the code. You can see in the left side image. So this is the code that we have written, and in the right you can see the output. So here you can see the blinking of an LED light. So uh, we need to configure the pins here accordingly, so we can see a LED blinking here. So next slide. So this is the next one, next code, the CLCD code. So you can see the code here in the Arduino IDE, and here if you see that LCD print home automation, and if the same appears in the output in the picsimlab. So we need to configure in the same way the pins here accordingly as mentioned. And so you can see in home automation a message bringing on the CLCD. So next, my friend Ramsida will continue.
Hi, my name is Ramasurya Vamsi. Uh, I am currently studying at SRM AP, BTech third year, ECE. I am going to explain about few other topics which we discussed. Uh, Here we ADC refers to the analog to digital converter, and in this we take the components like CLCD and potentiometer. We need to give properties respect to each component we have taken, and we can see that we given delay as 1,000 milliseconds. As we increase the value of the potentiometer one, the value on the LCD also increases. Next one. And we are taking next concept as a temperature sensor. We are displaying temperature in degree Celsius. Firstly we need to take the components CLCD and temperature system from the inputs and outputs, and we need to give certain properties with respect to the analog pins in order to print the temperature value on the LCD. And we need to give here LCD.print as a temperature, and in LCD.print we need to comment it as degree Celsius to obtain the value in Celsius. Next one. And the next one is PWM. PWM refers to the pulse width modulation. For this we need to consider a LED, and we need to configure pin to the first LED, and also we need to give with the respect to properties. Next one. And next topic is controlling LED with LDR. LDR refers to the light dependent resistor. As we know that resistance increases, voltage decreases. As we increase the resistance of the in the LDR, the brightness of the LED decreases. So as we decrease the resistance in the LDR, the intensity of the light LED increases. Next one. For connecting the devices through phone, we need to go to Blynk Cloud in the browser, and we need to create an account with respect to mail ID and password, and then we need to create a template. In the template, we need to go to the data streams, and we need to give each data stream. We need to consider each data streams, and we need to give each pin value. Here are the data streams. First one is switch, and we are giving the pin as a v0, and its data type is integer, and we give the minimum and maximum values as 0 and 1. The second data stream is temperature, and it is connected to the pin v1, and its data type is a double, and its minimum and maximum values are 0 and 100. And the third data stream is a virtual pin 2, and we give the pin as a v2, and its data type is integer. We give the maximum and minimum value as 0 and 1. The fourth data stream is virtual pin 3, and we give the pin as v3, and its data type is integer, and the maximum and minimum values is 0 and 1. The fifth data stream is virtual pin 4, and we give the pin as v4, and its data type is integer. The maximum value is 1, and the minimum is 0. And the sixth data stream is virtual pin 5, and we give the pin as v5, and its data type is integer. The minimum and maximum are 0 and 1. And next, our teammate Yuvraj will continue.
Hi everyone, I am Reddy Yuvraj. I am studying third year ECE from SRMAP, and I am continuing Blynk Cloud configuration, the last pin V6, which is we called it as name string V6, and data type is a string, and it has a default value. And here, the above we discussed all the switches are shown here, which temperature, virtual pin 2, virtual pin 3, virtual pin 5, string V6. And coming to the next slide, here we made this in the Blynk application in mobile phone. Here two tabs we have created. In tab 1, there are 4 columns. We informed about them all in these 4 images. First, we are going to the cooler. Here we took the switch as a data type and data stream, and here the switch pin is V0, and the mode is switch. And next, heater. The heater pin is also virtual pin 2, and mode is switch, and virtual pin 2 is V2. And next, the temperature gauge. Here the temperature gauge pin is V1. And next, notification column. Here the string is this, and pin name is string V6. And moving on to the next, here the tab 2, here are 3 columns, and one is inlet valve. Inlet valve pin is virtual pin V4, and next one is outlet valve. Here it will having virtual pin V3, and next water volume. It is having virtual pin V3. Sorry, outlet valve is virtual pin V5, and next last one is we are showing the status of the signal. Here it is a home automation about some other friend taken this image. Here we are seeing that our system is in online like that. And moving on to the next slide. Here this is the final output what we have simulated this project class. Here we have seen the notifications and the cooler. We have seen the temperature and inflow and serial remote tank here, and some Ethernet shields, etc. What we have learned last in previous slides, Ethernet shield, LEDs, LDR, etc. And now we are moving on to the simulation. Here we are going to continue the simulation. I am starting the. I am connecting my mobile phone to the system. Right. Okay. Check. Sorry for the interruption. Here are the uh, here is the simulation. We are seeing now the serial time, and I am connecting to the cell phone to the device. And here we saw the outlet and cooler, etc. component. I am now trying to switch on the cooler. Here, here we see the cooler is turning on and it's rotating. And we also see here there are inlet valve and outlet valve buttons. I am turning on outlet valve. Here we see the water level is decreasing rapidly. At the time of it's going to 2000, it will turn on the inlet valve. Yeah, inlet valve is turned on. If we turn off the outlet valve, it will reach the maximum in a less time. Like this. Yeah, now the valve is filled. And here we know these are the notifications when we get the water level will go beyond the 2000 liters. And we also see that when we turning off the heater on the heater, here we saw the readings of the temperature in the room. When it goes higher than the 35 degrees, the heater will turn off. Then we will turn on the cooler. We will see the temperature is also decreasing now. Yeah. Yeah, now we're going on to the code. Here the code what we have done in this project, the home automation code. And now we have seen the some different template IDs, link device name, and authentication token. These are the IDs which we have to connect the picsimlab through the Arduino IDE and Blynk configuration. This is the LDR code which we have to uh, turn on the lights LED in the garden, and this is the code for the serial tank. What we have sun in the simulation, and this is the code for the temperature system, etc. Moving on to the moving on to the here is the conclusion. The home automation using the Internet of the Things have been proven to work satisfactorily by connecting simple appliances to it, and the appliances were successfully controlled remotely through the internet. And we have now we are used LED, heater, cooler, etc. and water tank level indicator, etc. And uh, this project enhances lives for futuristic features that include saving of water and electricity by using IoT. This project is capable of dominating output supporting the user's device. Thanks.